Good afternoon, and thank you for joining us on today's webinar titled Efficient High Protein Feed Production for Revenue Diversification. My name is John Nelson. I'm Vice President at BBI International and Ethanol Producer Magazine, and I am joined today with Adam Anderson, who is a Product Manager at Icm. A couple housekeeping items I'd like to go over before we get started here is, first and foremost, this webinar is being recorded and will be available within 24 to 48 hours on ethanolproducer.com. So if you want to share it with people, you want to review a few items, it will be available and up, and you can check that out on ethanolproducer.com. The second point I'd like to go over is if you do have a question, and we definitely want you to ask questions. So if you do have questions, you can see it in the questions area in GoToWebinar. You can post your question there, and we will hold them to the end, and we will ask Adam. We'll grill Adam at that time on all the questions that are coming in. So with that, we are going to hear a word from our sponsor, Icm.
ICM is proud to sponsor Looking to the Future Today, ICM's approach to efficient product diversification, a webinar series hosted by BBI International. Since 1995, ICM is focused on innovating and developing new technologies to support the production of renewable fuels and animal feed. More than 100 biorefineries worldwide have adopted its proprietary systems, designed to help plants realize higher profits and better operational efficiencies at every step of the process. A global leader in the biofuels industry, ICM offers design, engineering, manufacturing, implementation, and plant support. To date, ICM has completed more than 5,500 projects across more than 300 locations, including over 30 plant retrofits. Want to know more? Visit icminc.com or any of these social media platforms.
Okay, I think we're go now. I'm looking around the room, and it looks like we are. So yeah, this is Adam Anderson. John, I want to thank you for the introduction, and I really want to thank BBI for the opportunity for hosting this webinar and this webinar series. So ICM's doing, I think, a 4-part webinar, and I was asked to open the webinar series up, kind of doing a high-level introduction to our APP system, and I was very excited at the opportunity. It didn't take me very long at all to raise my hand to say I'd do it. And what I'm going to do today is really kind of go through 3 parts. The first 2 are relatively short. I'm going to talk about the economics of the industry relatively briefly, got a couple slides to show, and kind of just share a picture of how the industry could be viewed from the economic standpoint, and then go into a little bit of feed diversification and the market opportunities that are out there and are projected to be out there for high protein feeds. And then from there, I'm gonna transition right into our ICM APP system, which is the system ICM has developed to produce a 50% yeast-enriched high-protein feed product. It's the system that's been running for close to 2 years here in Colwich, Kansas, at our Element facility, along with the Andersons. And so, again, very, very excited to do this. And as we've got our title slide up, and I'm not having control yet, so hopefully John can give me that. All right, are we getting there? Wow, a little bit of silence, a little bit of here. I'm going to just ask for the next slide if I could, and I think we'll get there. And it's going to be the title slide. There we go. And on the title slide as it comes up, sorry for the technical difficulties here, but we're going to go back up to the title slide, and I really want to just highlight one word, and that's the word efficient at the beginning of the title. And that's one of the key things I'm going to talk about as I talk about our ICM APP system. And so the high protein and diversified feed topic has been around the industry for quite a while now. I know it's been close to a decade since the first plant I know of was doing a diversified feed product up in Wisconsin, running campaigns and doing a good job, making some money doing it. And then about 5 years ago, really the ice started to break a little bit, and this technology and these feed products started to come online more and more. And we're at a place now where some markets have been developed, and there's some really good opportunity for plants to diversify and make money. And so ICM has been in a position of looking at ways to help producers out, get a technology developed that can do this and produce these diversified feed products very efficiently, essentially to do it in the most efficient way possible. And not only do we want to do it efficiently, we want to be very user-friendly. And so come up with a technology that doesn't bring a lot of new pain to the producer as they're running it. And then also, obviously, a key when you're talking about efficiency, it really drives down to being the lowest cost producer. And so as ICM develops these new technologies, that's always our focus, is to do it in a very user-friendly way and to do it in a way that allows the producer to do it at the lowest cost possible. So that's where we're going to be going today, and I'm going to start out just talking about the state of the industry economics. And this is a table and a chart that I really like to show, and I think I've got control back now, so thank you, John. I think we're over the hump. That was probably actually on me. I don't think I got the cursor up on the presentation, so I apologize again. But anyway, back to the presentation. So I've got a chart that's up there, and this is actually a chart that anyone can generate themselves. So I think most of us have access to a Google machine anymore, and if you go to Google and you type in ethanol margins, Iowa State, the great University of Iowa State has a nice little website that you can go to, and you can actually get up-to-date views and advantages of not only ethanol, but also biodiesel. And this is a chart that our marketing group actually was able to develop using information from there. You can actually download the data, and you can create your charts. And what this is showing is essentially how an ethanol plant, a typical ethanol plant in the middle of the United States, actually specifically in Iowa, if it's subjected just to typical industry economics, this is their picture in terms of making money. And if you can follow my cursor, I'm gonna highlight basically the $0 line right there, and that's the return over operating costs with about an 18-cent fixed cost applied to it. And that's giving you a real picture of what, again, a standard ethanol plant in the middle of Iowa, their opportunity to make money or to lose money over the last roughly 6 or 7 years, so back to 2015. And what's really kind of painful, and what maybe the industry doesn't think about enough, is that the number of times, as I'm circling them, where this ethanol plant, again, just subjected to standard market conditions, is losing money. And obviously that's not something we as an industry want. We're enjoying a really good prosperous time here in 2021 where markets have shifted. They're in our favor right now, and we're making money, and it's fun to talk to customers when they're making money. But again, a lot of times we don't have a whole lot of control over it, but what we can do by applying new technologies and looking at new opportunities to make money differently, because we can add to that bottom line. And so the green line that I just put up on the table gives you a picture of what an ethanol plant's return, or what this ethanol plant's returns would be if they were able to make 13 cents more per gallon of ethanol produced. And so hopefully what you're able to see is that there are still some windows of time where the plant is going to be losing money, but they're minimized. And then obviously the periods of time where they're making money are significantly better. So again, with this chart, just trying to give that picture, maybe pain's too strong of a word, but really, if the economics aren't favorable and a plant's not making money, it's not a comfortable time. So moving into why that is, why are we as an industry maybe limited somewhat, and really what it boils down to is, the costs of our inputs and the value of our outputs. And a baseline ethanol plant, as shown on the screen now, is really pretty limited in terms of the feed products and the overall products that it's able to produce. And so we've got ethanol, which is, again, is a great fuel, a great product. It's built the industry. It's made the industry a ton of money if you go back far enough. Really good product, but again, somewhat limited in terms of future opportunities. Corn oil has been a great product throughout the industry. For over 12 years now or longer, or actually 15 years, I guess you could say, we've been doing a really good job of extracting corn oil, and there's been a significant increase in the yields and the amount of corn oil that we've been able to pull out here over the last 2 to 3 years. It's been a high focus. but again, in terms of future opportunities, somewhat limited. And so as you go down to the bottom pile shown on this slide, you can see the dried distillers grains or even the wet distillers grains. That's really where we see the greatest opportunity for improvement. And a big reason for that is because Ddgs our nutritionist likes to say they're a perfectly imperfect feed. And what they mean by that is it's a valuable feed component. It's, the components of the corn kernel that have been through the ethanol process and now they've come out the back end and there's value there, but as they sit, it's a combination of the protein and the yeast and the fiber and the oil that's not really uniform and perfect for any end user. And so the industry has done a really good job over the last 20 years developing markets and maximizing the value of it. And I talk to producers now and they're getting 110, maybe 120% the value of corn out of their Ddgs, and that's great. But as that stands, there is the opportunity to do things a little better. And really what it all boils down to is these feed species, these end users that you're able to sell your product into. And so what this slide is showing you is that, the darkest tinted species, the ruminants, the beef cattle, and some of the dairy opportunities, that's going to be the species right now that Ddgs as it sits feeds best into. And then there's some opportunity with swine, some opportunity with poultry. But standard Ddgs, in terms of having an opportunity into the highest value, highest opportunity markets with aquaculture or pets or even beyond, there really is no opportunity for standard Ddgs. But if you can take those components of the dry distillers grains and you can fractionate them out, separate them out into a clean pile of fiber, into a clean protein stream or a concentrated protein stream or a concentrated protein and yeast stream, you can open that door to being able to sell into these higher value opportunities. And so that's really what the focus of ICM's APP system is it's giving the ethanol plant, giving the biorefinery, whatever they choose to be called, giving them the opportunity to diversify those feed products and maximize the value of that process stream coming out the back end of the plant. So I want to focus on the protein moving forward. And we do get the questions of, is there a demand for protein to go beyond? If every ethanol plant in the country, adopted a technology to allow them to diversify their feed and produce a feed protein, a high protein feed, is that market going to get saturated? Is it going to decrease the value, or are we going to, completely saturate it to where there's no home for it? And we like to confidently say that, pretty much the opportunity for protein is about as close to unlimited as it could be as you look at world population growth, as you look at, just the opportunity for protein to continue to be a product in demand. This is one study we like to reference from the FAO Agricultural Outlook, where they talk about by the year 2030, there's expected growth in beef, swine, and then the poultry and the aquaculture, getting up into the, 19%, 13% growth, 43% growth, 35% growth. That's significant growth expected for these markets. And, I also get the questions on some recent news with the soybean meal facilities that are being built. And those are all, really good projects, I think, that will be going on. But as there's more soybean meal out in the industry, there's still going to be a value for a corn protein coming out of an ethanol plant. And we like to say that as the soybean meal has a certain price point, there's a pretty consistent history of there being a spread between that soybean meal and distillers grains, and then even to corn. And so as soybean meal, more and more of it comes online, there's still going to be that demand for a feed product. And if it is suppressed, well, that's likely going to mean that the distillers grains and even the value of corn is suppressed as well. So there's still going to be that opportunity for a higher value feed product in terms of it being kind of a high protein yeast enriched feed product. So those are kind of my opening slides on the economics and the high protein feed market. And from there, I really want to get into the ICM approach to how we're taking a standard ethanol plant and applying some of our newer technologies, combining them together to allow a plant to take that kernel of corn and the other inputs that come into the ethanol process and separate them out so that on the back end of the plant, they can have a diversified feed product that is tailor-made for their opportunity to make the most money. And again, at the end of the day, that's kind of what it's really all about for our producers and their sustainable future. So ICM's APP system is the combination of our selective milling technology, our fiber separation technology, our feed optimization technology, and our thin stillage solid separation system, TS4. So these 4 key technologies, all of which ICM has been working on for many, many years, these combine to form our advanced processing package, or our APP. And so where I'm going to go now is I'm going to kind of walk you through how these transform the ethanol plant, allow kind of some newer diversified feeds, and then mainly how they integrate fully into the ethanol plant. So it's not just a kind of an add-in technology on the back end or pulling from one specific part of the plant. It's fully integrated into the process, and there's a number of efficiencies and opportunities that come along with that approach. And there's also a number of clean process streams that we separate out within the plant, and I want to kind of show you where those each apply as well. So first off, the baseline ethanol plant, as you add the advanced processing package, or the APP, the core benefits that are going to come out of it, right there on the bottom, are the diversified feed products. Most specifically the yeast-enriched 50% protein, what we are calling Protomax, what Element is calling and Vantage 50Y. That's the feed product that's going to bring the highest return in terms of market value. So that's the opportunity with APP. Along with that, the plant can produce a dry distiller's grains, exactly like what they're producing today, or they can produce a sole bran or a high energy feed, which is a separated fiber combined with the solubles, a high energy feed product. And I'm going to walk you through kind of towards the end of the presentation, how those, basically the levers that you have to be able to do that, and how basically what's changing between that approach is the yields of the Protomax. So if you have more Protomax produced, you're gonna kind of turn towards the sole bran being the remainder feed product. Whereas if you want to go to a medium or a less of a yield of the Protomax, you're going to have your standard distiller's grains. And again, it's levers the producer can pull to maximize their feed opportunity. And then also I want to kind of note that on the corn oil and the ethanol, we've got some pluses up on the screen. And those really hint to one of the key benefits of the system is the opportunity for it to unlock potential, remove bottlenecks, and allow a baseline ethanol plant to potentially produce more ethanol, to potentially produce more corn oil, and take advantage of those efficiencies and those kind of process changes that come along with the Icm technologies. So this is a kind of a transition slide. I'm showing you essentially the dots or pictorials of the clean process streams that are going to be flowing through the ethanol plant that has our APP system in it. And so we're going to have a clean fiber pile, we're going to have a concentrated protein pile or process stream, an enhanced protein with yeast process stream, and then kind of a different and a new solubles or syrup process stream, and the distiller's corn oil. And you're gonna see on these next few slides, as I show some process flow diagrams, where these play and how they kind of are separated out within the ethanol plant process. So before I go into that, I'm going to start with just the baseline ethanol process, kind of an ethanol 101 type slide, and really kind of just focus on what we're doing with the mechanical and the chemical and the biological systems that are in place, and kind of talk about how when we add the APP system on there, we're really just adding some capabilities for particle size separation and density separation to plug and play within this process stream. And so as I'm going through the next few slides, it's good for you to know that I'm kind of moving from the top left to right as we go through the front end of the ethanol plant. If you can follow my cursor, again, just from the grain going through milling, through liquefaction, and then we drop down, and the middle row kind of goes from right to left, fermentation into distillation into dehydration, and then we've got our one end product being the ethanol. And then out of distillation, nice little arrow dropping line down into the whole stillage decanters or the centrifuges. From there, we do a nice separation in our baseline ethanol plant with liquids going to the evaporators, solids going to the dryer or to a wet pad. And from there, we've got our dry distiller's grains of solubles. And then out the evaporators, you can do another separation out to get your distiller's corn oil. So this is the base process flow diagram I'm going to be using. And as I go to the next slide, boom, we're going to drop the APP process right on top of it. And Now, as I move into each one of these technologies, I'm gonna kind of advance the slides, and we're gonna see these kind of be highlighted in green, and that'll give me a slide or two for each technology to talk about them a little bit independently. And each one of these technologies does provide value on their own. The selective milling technology we've put into 40 plants or more, and we've seen significant benefit from that. But what I'm talking about mainly today, just due to time and due to focus, is how these technologies kind of plug together, play together within the APP system, really driving us towards those high value, high protein products. So as we highlight the first one, we're going to highlight the front end of the plant, and we highlight not only the SMT system, but the milling as well. So one of the key things that we want to do within the APP system, since it's fully integrated, since we're looking at doing separations throughout the entirety of the plant, is we want to start at the very beginning and not make a powder, not make a really, really fine product out of the dry kernel corn if we don't have to. And so the first thing in terms of a process flow from front to back, the first thing we're going to do chronologically, you might want to say, is with the milling, we're going to do an adjustment to the plant, and we're going to adjust their milling system, their dry milling system, and give them an upgrade that allows them to do the same thing in terms of preparing the corn kernel for conversion to ethanol, but we're going to do it in a way that does not break down the particle size of the fiber. So the front end technologies that are driving towards this clean fiber pile that's going to be going towards the back of the plant, our front end technologies, a very significant part of them is particle size separation, going through what we call multi-zone screening apparatus. And that's going to be my first plug for future webinars. So I'm going to make hints and references towards some of our actual pieces of equipment on my presentation today. But in one of the following 4 presentations, we're going to go into quite a bit more depth into the specific equipment itself. So as I referenced it today, I'm not going to go into a whole lot of detail, but I'm going to talk about the benefits that they bring. And so since we're doing particle size separation, and even on the back end of the plant when we're going into centrifuges and doing density separations, we very much want to preserve as much of those larger particle sizes as we can, and most especially with the fiber. So doing that modification of the plant's dry milling system gives us that opportunity. And then moving forward, the SMT is a selective milling of the wet process stream, and so that brings a benefit with it as well. And so SMT is, you can see a picture of one of our single skids over here on the left, and on the top level, we're going to do a dewatering through one of those MZSAs, and then we've got a milling apparatus in the middle. This is a disc mill, I believe, in this picture, or it might be a roller mill too in our SMT V2 skid. But anyway, we're doing a wet grind and a nice aggressive grind of the larger particles in the liquefaction flow that have the most opportunity. Those larger particles have the most opportunity of passing through the front end of the plant, not allowing their starch to be broken down and available for ethanol conversion, or it's protein and fiber and other larger particles that are bound together and not able to be separated like we want them to be. So our SMT does a good job of doing that. And again, with the grind, our front end, what I'm going to call dry grind upgrade, we're able to get a right-sized grind. We're in this picture, if your screen's clear enough, you can actually see the larger sizes of the fiber, or the pericarp, which is that outer layer of the corn kernel. And you can see that it's prepped and it's very well set up to go through our separation devices on the front end of the plant and allow that fiber to be cleaned and washed and separated without, forcing a plant to try to separate a fine grind, powdery, broken down kernel of corn that's brings difficulties along with it. So that's what we're doing at the front end of the plant. From there, we're going to move into our fiber separation technology. So with our milling and our SMT, we've prepped everything. Prior to that, with slurry and liquefaction, we've given the necessary time and temperature, the opportunities for the biological processes to start, the chemical processes to happen. And now we move into our FST, and our FST is really a workhorse of the system. The FST is where we are doing those particle size separations of the fiber and then doing a countercurrent washing of it, washing the protein, washing the starch, washing the fats and oils away from that fiber so that they can flow through to fermentation where they bring the most value. and then that clean fiber pile can bypass fermentation, and it can bypass distillation. It can avoid the plate and frame heat exchangers that are involved with fermentation and the ones that come before it, and the beer mash exchangers. It can avoid the pumps. You no longer have the fiber providing wear, and it can avoid the beer column where really there's just zero value in the fiber being there. And so we take that clean fiber, we separate it, we clean it, and we allow it to bypass those middle parts of the plant. And along with that, we bring that opportunity for increased plant rate. If fermentation, if distillation are a bottleneck for a plant, FST can bring up to 14%, a 14% increase in grind capability. So that's a pretty significant opportunity. And a couple of the other things FST is doing is off the back end of our FST system, as we're doing the dewatering and then the washing and then the dewatering, our final dewatering device is what you can see in the picture on the left. It's a Rotary Press. This is a very exciting piece of equipment. Icm's partnered with Fournier. That's one of our vendor exclusive partners that's been very strategic for us, and we've modified this system from the wastewater treatment industry. And what you're able to get off the back of this press is what you can see in the video here, and it's probably just a little glitchy, which is okay. But coming off of, this is actually Mark Autry's hands. I'm gonna just say it. Mark Autry reached in there and grabbed the fiber, and as he does that little separation with his left hand, you can see just how clean and I'm gonna say dry that fiber is. And this is actually one of the highlights of the tours for me. One of the highlights of the tours as we have customers and other vendor partners come through our element plant. We get to the press and we've got a sample portal right there, and you can get a sample of this clean fiber. You can put it in your hand after it's cooled a little bit, and you can rub it together, feel how smooth and non-sticky it is. You can tell that the sugars, the starches are just gone. And the really cool part that does is it's now a process stream that is 40 to 45% solids, and that's what heads to the dryer or to the wet pad. But if that is going to the dryer, that's now again a 40 to 45% solids process stream going to the dryer, which has significantly less water than what the wet cake would be coming off of a baseline ethanol plant centrifuge at roughly 35% or 36% solids. So that's one of the key benefits of the system, and one of the ways that we're able to reduce natural gas and provide some CI, some reduction in CI scoring is through that reduction in natural gas due to feeding the dryers a product and a process stream with less water load to the dryers. So that's our FST system. Again, one of the key workhorses of the system, and multiple benefits come along with it as we're doing the separation of the fiber in front of fermentation and distillation. So now we'll continue to move, and we'll get to our feed optimization technology, or our FOT. And FOT is a really cool new technology, because what we're doing is we're taking the plant's existing centrifuges or decanters, that are typically handling whole stillage and just dewatering it and sending a wet cake to the wet pad or the dryers and sending a liquid flow thin stillage towards the evaporators or back towards backset. We're taking that process step, and we're going to upgrade those machines. And this is where we work exclusively with our other strategic vendor partner, or one of our other ones, Plotwig. So if a plant has existing Plotwig centrifuges, we're going to take those machines and we're going to modify the internals, and we're going to modify the drives, and we're going to add a wash stage in the middle and basically turn that centrifuge step, that centrifuge process, into a two-step process. And we're able to do that due to those modifications that we've made to the centrifuges. And then for the customers we're working with that don't have Plotwig machines, they've got a different provider. Most of those plants are kind of in a life cycle, or those specific centrifuges are in a period in their life cycle where they're near limiting out anyway. So we're going to do a replacement of those machines, add the Plotwig machines with the new internals, with the new drives, give them machines that have that increased capacity, increased ability to do a separation, a density separation, and have that run through the FOT process. And coming out of the FOT process, we've got some other videos that I want to show you here. So first I'm going to show you a picture of what that new internal scroll, it's actually called an accelerator scroll from Plotwig. That's what that new internal bowl scroll looks like. So instead of having your normal cylinder looking bowl that fits inside of the Plotwig machine, this is what it looks like, and you're able to get a deeper pond depth and do a more aggressive separation with this, as well as having more capacity within the machine. And again, we'll go into that in more detail and more depth in a future webinar. But I've got another kind of cool video to show here. This is the new cake that comes off of that second pass of FOT. And so this would be the new product stream heading towards the dryers. This is the concentrated protein, the highest protein concentration that can be 57% crude protein or plus, depending on how you run it. But again, you can see how it flows through. This is Jeff Sharping's hand, I believe. I'm throwing names out here. But this is, you can see how the wet cake, if it normally comes off a standard decanter, it's clumpy and it clicks together, and as it's feeding the dryer, you can kind of just feel and sense the moisture load that's in there. This cake looks and feels a lot different. And again, this is another process stream we can show as we do the element tour, and you just get that feel for how it's just different and how it's a better process stream to feed the dryers. So that's a fun video to share. And then after FOT, so I want to highlight, again, coming off of FST, we have the clean fiber pile. Now coming off of FOT, we've got the concentrated protein stream. And then the liquids that come off of FOT, kind of that standard thin stillage process flow now without the fiber in it. That's what's now feeding our thin stillage solid separation system, or our TS4. And TS4 will be, chronologically again from front to back. That's going to be the last ICM technology that we're flowing through. And what TS4 is it's another set of Flotwig decanters, Flotwig centrifuges, but these ones are actually Sedicanters is the name of them. So a little bit different machine, different setup, and again, we'll go into more detail on exactly how they're different later on, but they're basically designed in a way that gives a greater G-force that allows us to do a more significant separation, density separation on that thin stillage stream that has, suspended solids that are lighter, fluffier, a little more difficult to separate out through a standard machine. So we're able to do that with these Sedicanters from Flotwig. And then the cake that then comes off of these Sedicanters, we call it Sedi cake, but this is the yeast-enriched protein concentrated pile. This is what it looks like as it flows out of the Sedicanters. And you can just kind of see the almost soft serve ice cream type feel, but this flows really well back into the conveyors. It mixes really, really well with that other concentrated protein stream that we talked about that comes off of FOT. And so these combine together to produce the Protomax feed product. That's a little too jerky on a normal presentation. I'll let this flow for a while because it's fun to look at, but it's definitely a unique and a neat process stream to handle and to feel. And then the liquids that come off of TS4, any producer, any vendor, anyone that's been around the ethanol plant and seen a spin down of thin stillage can relate and recognize what these vials are showing. And so a typical thin stillage sample, if you put it in a centrifuge and spin it out, you're going to have what we call a pellet, or a layer of solids that show on the bottom of the tube, right around that 10% range or more. And so that's what this picture is showing. With our TS4 system, as we've removed those suspended solids, the spin down pellet is a lot smaller. And the way I like to best describe TS4 is, so on the back end of the ethanol plant, you've got really two systems that are dewatering final products, or products going towards the back end of the plant. You've got the dryers and you've got the evaporators, and the evaporators by design do a really good job of evaporating water out of a liquid. So that's what they do, and the dryers do a really good job by design of drying water out of a solid. And what TS4 is doing with this thin stillage stream is it's taking these, 50% or more of these solids, these suspended solids, and sending it to the dryer, where the dryer can dry the water out of it most efficiently. And then the remainder of this liquid, we're going to allow that to go to the evaporators without those solids in it, so that the evaporators can evaporate the water out of it most efficiently. So that's what TS4 is doing. And another key thing that the TS4 is doing, as it sends less suspended solids to the evaporators, we're now able to run the evaporators differently and drive the solids up within the syrup or within the solubles. And as we're doing that, what's been really neat to see is that we increase the solids within the syrup, but we don't increase the viscosity. So as we do it, we're not seeing a huge gain and buildup and plugging in the evaporators. We're not seeing a discoloration that affects the Hunter score of the feed product. We're literally just letting the evaporators pull water load out and then produce clean water from that evap condensate, but ultimately do it more efficiently and do it better. So this kind of gives you a picture of what a standard plant thin stillage would look like, and then this middle picture is one of the highest solids syrup flows we've done through our testing and through some of the stuff we've done at Element. So it's a little darker than what a typical APP plant's going to see, but it's a lever an APP plant will have for potential future use, which is pretty cool. And kind of driving towards the end of the presentation, the last thing we're going to highlight and talk about is the Icm Rotary Dryer System. And this is one I'm pretty passionate about. I've been with Icm for 17 years this month, and I started working for the Icm Dryer Group. And I was pretty blown away as I came into Icm and saw just all the levers and all the complex controls, everything that we had within our dryer system that could give a plant a bunch of different ways to run the system. And of course, in that 2003, 2004 window, all those levers kind of got pushed aside in favor of maximum production, maximum production, maximum production. So it's been really exciting for me to see as we've shifted towards a more specialized high protein feed product, we've been able to better utilize, and again, that's Adam Anderson's view, better, all is good. But we've been able to really see what the dryer system can do with a concentrated, high value, high protein system, how we can control the temperature, we can control the airflows, we can do what's needed to gently dry that product and allow it to get the maximum value as a feed product. So the Icm Dryer System, I think we got a picture here of our shop of one of the drums being built. Again, there's over 400 of these out in the industry. It's a very, very successful product, if you were going to call it a product. From a product manager's perspective, about as successful as you can get from something that kind of came from nothing and went in and changed the industry. But a really cool thing that this does is for any one of the plants out there, the numerous plants out there that has the existing Icm Dryer System, we're going to put the APP system in, and we're going to run the high protein through your existing dryers, allow you to produce the high value 50% protein feed product without having to add a new dryer, without having to add the CapEx and the ongoing OpEx, and again, that kind of lack of user friendliness that those potentially bring. We're doing it here at Element. We love showing that off, watching customers, pull a sample off the back of the dryers of the Protomax or the Advantage 50Y, feel it, touch it, taste it if they're so inclined, and see that that's being done through the Icm dryers is a very, very good and exciting thing. And so driving out of there, just a little bit, I've got 3 or 4 more slides. Again, now just focusing on the feed products themselves, and again, back to the process flow diagram where we have the clean process streams. Start out with that protein stream, that concentrated protein stream that came off of the FOT system. That gets combined with the enhanced protein with yeast that came off of TS4. So those two are what are combining together to produce the Protomax feed product. So that's a good way to, simple little math variable addition to show you how we're producing that. The Sol brand high energy feed product, well, that would be that clean separated out fiber combined with the syrup or the solubles. So that would produce the Sol brand. And then if you're wanting to produce a standard distiller's grain, again, something you absolutely can do with our system, we're gonna take the protein, we're gonna take the bran and the syrup, and we're gonna combine those together. And this protein is basically what you're able to trim off and produce this dry distiller's grain at whatever protein spec that you're wanting it. So this is a good way to kind of show you how we're allowing a plant, allowing a customer to combine the products and combine the process flows to produce the feed products, to give them the greatest opportunity for making money. And again, what that looks like in terms of opportunities with the end users or the species or the feed markets. So the 50% protein could still be fed to beef cattle, but I'll be honest, they're not going to pay enough for it. So that's there could still be benefit there, but that's maybe a future play if they ever see the value. But specialized dairy would have opportunity, and that's kind of what we would consider the floor pricing. But there's opportunity there. And then you can very much get into the swine and the poultry and the aquaculture and the pet food arena with this feed product. It opens those doors, gives the ethanol plant that opportunity to get the most value possible out of a feed product. The sole brand, so if a plant is maximizing their yield of Protomax and they're producing a sole brand, again, it's a high energy feed, very well suited for a ruminant, for both beef and dairy cattle, or cows, dairy cows, beef cattle. So again, great opportunity for the high energy feed. And then obviously standard distillers grains are going to go into whatever market the plant has already, worked decades to develop and to sustain. If that's where their best opportunity for money is, then yeah, standard distillers grains can continue to feed those markets. And then just one more picture about how these play out in terms of the yields. And these are just theoretical numbers, but good knowledge for folks to have. So if you wanted to do a traditional dry distillers grains, kind of the place you would start out in terms of a Protomax yield would be in the 3.25 pounds per bushel. So if you're producing that much Protomax, you're going to have a remainder of roughly 11 pounds per bushel of traditional dry distillers grains. If you wanted to flip that and maximize the Protomax and get to 5 pounds per bushel plus, and this is what Element is doing today. They've actually been up in the 5.7, 5.8 range, I've heard, as they're maximizing their production rates of Protomax. Their remainder product is a sole brand, and what's really unique and cool about their sole brand product is they're running a modified feed product, but we're able to call it a non-thermal modified feed product in terms of, they're getting in the 45% solids range for a feed product without any pass through the dryer. So that fiber coming off of the press and the solubles coming through their evaporators are at such a high solids rate that they're able to basically sell a non-thermal modified feed product, not having to go through the dryers at all. So that drives us to one of the final slides here, which is the financial benefits of APP. And this is what we call the Waterfall Chart. So as we work with our customers, we ask them for inputs, kind of just standard operating parameters that they run their plant at, kind of standard marketing values that they see for their inputs and their outputs. And then as they give us that information, we're able to work with them to help see what it would look like for the advanced processing package to fit into their plant. And this is an example, just kind of a canned standard example that we felt, could relate to most of the audience, hopefully, as they're watching this webinar. But this is a baseline ethanol plant. It's running 130 million gallon per year rate before the APP system. Then as they would bring the APP system on, there would be a base plant change in terms of some additional electrical loading, some additional maintenance costs, some things that are real and part of a new system that we're not going to try to hide. We want to be open and honest with that about the customers. So there is an increase in expense to running the system. But on top of that, this is a plant, I think it was in the model, was producing 3.25 pounds per bushel of the Protomax. They were drying all of their distillers grains and Protomax. So in doing that, there's a natural gas savings of about $2.6 million. And then also with this, there's a CI score reduction of between 2 and 4 points. And there's a value to that for a plant that would be selling their ethanol gallons into one of those markets. And that's actually a chart we can add right in between the differentiated feed and the total EBITDA. We can show the value of that CI, but we also know there's a number of customers that right now don't have that opportunity. And so we're not going to inflate our payback and just throw it in there and try to pretend it applies to everyone when it, most likely doesn't. But it's definitely worth noting that opportunity is there. And when you add that, 2 to 4 points for those customers, it's significant. It's in the millions. And so, if that's something a plant's able to do, that's great. And then, so this baseline 130 million gallon per year plant with the FST system, just make some assumptions on what their bottlenecks are that aren't allowing them to run a little harder. And we know that with the FST system, we could very easily get them up to 140 million gallon per year rate or more But for this model, we capped it at 140 million gallons. And so that added around $7.3 million more. And again, that's very site specific. That's something we partner with each specific plant to show them their opportunity for that. And kind of the same thing with the corn oil yield increase. So I think this plant we modeled it starting at right around 0.9 pounds per bushel for a distiller's corn oil yield. With the APP system, we had them bumping up to 1 pound per bushel. That's essentially where we're at today with Element, in the high 9s with some campaigns running above 1. It's been a fun, I'd say, evolution for the corn oil opportunity at Element as they've really run and kind of worked to refine the system over these last 2 years. So anyway, in the model, we're saying there's about a $2.6 million increase or opportunity with increased corn oil yield and production rate. And then on the differentiated feed, this is obviously where the highest return is going to be. And so at the 3.25 pounds per bushel of Protomax, that's adding over $28 million per year to the plant's bottom line. But again, in doing that, there's a reduction of dried distillers grains production. And so again, there's a significant addition, but there's also some subtraction, and it's not something we're wanting to hide within our economic model. We want to be open and honest about it. I mean, because at the end of the day, this all adds up to a significant payback of 2.3 years, for a $57 to $60 million type project range. I mean, you can do the math, taking 24.8 times 2.3. But again, cost for a system like this is going to be different for every plant. The way we're fully integrating into the plants, we want to do as much as we can to take advantage of investments plants have made in themselves over the years, allow our system to plug in very well with them. But also, the production and the quality of the production is key. So there's just standard things that have to be done to allow the plant to produce the Protomax product, or the 50% yeast-enriched feed product. And moving into the summary slide, again, just the key benefits of APP is it's user-friendly, and it's the highest market-driven EBITDA uplift. So sorry to read the slide, but really being that low-cost producer, having that opportunity to produce a differentiated feed for the lowest operating cost has been a significant focus of ICM. We're excited to be where we're at with the APP system. The reduced carbon footprint opportunity, again, I mentioned as we looked at the waterfall that not every plant can take advantage of that today, but pretty much to the T as you talk to producers, that is a future development that they see as those markets and some of those, government or policy fights are taking place. That does feel like a wind that's in the sails of what's coming in the future. So it's a benefit that we're proud to have as part of our system. Again, being fully integrated within the plant, there's just a lot of benefits that come with that. And again, ICM obviously is proud of it. Again, opportunity to utilize the existing rotary dryers is a key part of that integrated technology portion, and something we're very proud of. And this is a key differentiator for our technology. And then ultimately, as we saw in the waterfall, those diversified feed products are what provide the highest percentage of the payback. And so again, that's going to be a huge focus for what we're doing. So with that, that's kind of the wrap up of my webinar today. Quick plug for the upcoming webinars. We've got a part 2 and a part 3 and a part 4 coming. Part 2 is going to be mainly focused on the feed, as one of our feed specialists or nutritionists presents and gives further information on the feed products. Part 3 is where we'll go into a little more detail on those specific pieces of equipment and really kind of, lift the hood a little bit to let you see how we're doing what we're doing, and provide a little more information on how those benefits and those efficiencies really happen. And then part 4, again, all this drives into the potential for the carbon intensity score reduction. So we want to help plants understand how we're doing that and why that can matter. So with that, John, I believe I'm to the final slide. I think we've got some time for questions.
we do have time for questions, and we do have some questions coming in. So appreciate you sharing your information with us, taking the time today. and discussing everything with our audience. We do have some questions, so I'm just looking at them right now. Here's the first question, and I actually have a couple of these, and I'm combining it because it's kind of the same question that's come in. Do you have the APP system up and running anywhere? If so, how many plants?
Yeah, no, that's a great question. It is just the one plant right now, and that's here in Colwich. It's the Element facility, and they've been running their 50Y, the Advantage 50Y protein product now for coming up on close to 2 years. And I think I plugged it and said it multiple times in the presentation that's a facility that is open for tours. We're very proud of what they're doing over there. Not only just for customers to see the process and to see how it's being done, but to interact with the operators, to interact with the managers, and really get a feel for, the work and the effort that they need to put in or maybe don't need to put in to consistently produce this feed product. It's pretty exciting. So yeah, great question. Thank you.
Right. Another question that we have is, does the 11-pound additional Ddgs contain post-fermented corn or fiber that has bypassed fermentation?
Hey, you broke up a little bit there. I think what you asked is, I think I had the one slide where it showed the yields, and there was the 3.25 pounds per bushel of the Protomax, and the other was the 11 pounds of dried distillers grains. And yeah, in that 11 pounds, there would be the clean fiber or the corn bran that did bypass fermentation. So yeah, it's not a process stream that went through fermentation.
Great. What is the benefit to producing sole bran instead of regular DDGS?
Yeah, so that's going to be a question that really depends on the producer itself. The core benefit I think we would see, and I think we even had I think Mallory Wilkin did a story recently in the BBI Ethanol Producers Magazine, where it talked about if you're doing the sole bran, that allows you to maximize the production of the Protomax. And so if you're getting the highest return and the most significant benefit from the 50% yeast-enriched protein product, the Protomax, then you want to make as much of it as you can. And that's what Element is doing. Like I said, 5.5, 5.6 pounds per bushel of their Advantage 50Y of the high protein. And then that remainder sole bran or fiber with syrup product to a ruminant market. We've done numerous feed trials, and we're doing kind of the marketing development now to prove that it's got on par value with dried distillers grains or, a modified wet distillers grains. So that's where the sole bran would come in, is if you want to maximize the yield of the Protomax, then your sole bran would be your other feed products that you're selling.
Great. This question just came in, and I'm glad it did because I actually wrote it down because I was curious myself. Can you arrange a site visit to the APP plant site? Yeah. So that's, again, the tour here at Element. And yeah, I've got 2 tours happening next week. I'm not going to tell you the customers' names. But yeah, we've been doing those for quite a while. The Andersons have been very gracious working with us. They're our partners back there, and it's a tour I think they enjoy allowing us to do, and they partner with us to do it. It's a very good tour, and we're happy to I'll just say it, we're happy to show it off. Great. And they should contact you then directly? That'd be a good.
Yeah, absolutely. Reach out to me directly, or any of your other ICM contacts, Neil Havern, Jeff Sharping. We're setting these things up and working with Element to make it happen.
Do you want to share your email specifically?
Sure. Yeah. It's just adam.anderson@icminc.com. Or call the ICM mainline number, and Mary Lynn up there she'll shoot right to me. I actually can see her from my desk. So.
Perfect. If she heard her name, she's probably looking at you going, "What?" No. So, with the system, can you still produce DDGS? with APPs?
Yes. Yeah, no, and that's a great question again, because it's a question we continue to get asked, and the absolute answer is yes. So again, within the system, just on the back end of the plant, we're giving the plant the levers to recombine those clean process streams to produce the feed products that make them the most value. And yeah, so I'm talking to a number of customers up mainly in the north and in the east, where they've worked pretty hard to establish a high value for their dry distillers grains. They're loading barges with it. They've got a certain protein spec that they need to hit, and if they don't hit it, the barge can get rejected. And so we're walking them through. If you've got a protein spec to meet, all we're going to do is take that clean protein process stream and blend it back in to those traditional distillers grade, whatever your feed tag is, and we give you the controls and the levers to pull and the measurement tools to see it, and you just line it out and you sell it that way. All you're really doing at that point is reducing the yield, again, of the 50% protein product. So yeah, absolutely, we can produce a dry distiller's grain traditional feed product along with the Protomax.
Great. And if you're making traditional distillers, what's the max high protein product yield?
Yeah, so the number off the top of our head is going to be 3.25 pounds per bushel, but again, that's going to be determined by whatever that protein spec is that the end customer needs to meet. And so yeah, that is one of the questions as we talk to our customers. You know, distillers grains are a pretty standard product, but there are, again, plants selling up to a 34% protein distillers grains, and there's others that can get away with a 30% protein. So depending on what they need and what they want for their traditional dry distillers grains, or what their opportunities are elsewhere, that's what we want to partner with them and help them see and help them get there.
Great. Can you install just one technology at a time, or do you have to do the entire package?
So to produce the 50%, the Protomax feed product, you need the full package. But if there are other opportunities for a plant, or if they're wanting to take kind of a platform or stair-step approach towards an APP, yes, we can do the individual technologies one at a time. And that's, yeah, we've been doing that for over a decade now. So, you know, with the technologies that I showed within this presentation. So yeah, absolutely. That's something we continue to talk to customers about, and systems we continue to propose and quote is some of those standalone, some of those technologies as just a standalone package.
Great. Question came in here. You commented on about 57% protein product from FOT system being possible. Is this dry matter, or is it protein? Yeah,
that's a great question, and I'm trying to remember the slide, and I'm off the top of my head, I don't know, so I'm not going to say yes or no. Yeah, so but I know what you're talking about. It's the cake off of the FOT pass, and so my gut is that is the as fed number, but don't hold me to that. So as received, so you know the dry matter basis would be different, but whoever asked that question, reach out to me and I can certainly answer it on a one-off basis. Because yeah, we definitely know that answer. I apologize, I don't know it off the top of my head.
Okay, no, not a problem. We'll definitely make sure you get in touch. What effect do you anticipate the expected increase in quantity of soybean meal will have on the market for high protein feed products?
Yeah, no, that's another really good question, and that's one we're getting, because yeah, there's been in the news recently, there's been quite a bit of talk about increased crush of soybeans, so there will be an increase of soybean meal, and the pretty candid answer is there is a good historical trend of soybean meal and distillers grains having a consistent spread between the two, and so we think that the opportunity and the market for high protein feed products is out there, and it's almost limitless. But if there were to be some kind of suppression of like a soybean meal price, that would translate into a suppression of distillers grains price as well, and so a suppression of corn price. And so we would see, again, that spread being there, so that if a plant had the levers to transition from distillers grains to a high protein feed product, the value would still be there. There'd still be a healthy return for a project like APP.
Great. And what kind of corn oil yields are you seeing with the system?
Yeah. So what we're talking to customers about is getting a pound per bushel of distillers corn oil. Again, Element being a first off type plant, they've done a really good job again over the last year, especially of really focusing on that and getting up into the mid to upper 0.9s, and then having some campaigns where they're at a pound per bushel or more. And we see opportunity to go higher as well. But again, obviously there's variables involved. So 1 pound per bushel is what we're modeling right now. And then if a customer sees opportunity for there to be more, man, that's a fun topic to talk about. And we're happy to see the reasoning and discuss how APP could play and potentially keep it the same or help it improve.
Great. We have a few more questions here. We're going to keep grilling you, keep you on the spot in the hot seat.
Good.
How do you control? Yeah, this question just came in. How do you control what goes through the dryer? Do you have a toggle? Do you have to toggle the two products, or do you need two dryers?
So that's going to be a site-specific question. So the main controls that we're putting into the back end of the plant are conveyors and blending capabilities. So VFDs, those types of controls, along with flow transmitters and mass density transmitters that allow us to make adjustments. But yeah, so I mean the dryers, you're going to have one dryer for sure needed for the high protein feed product. And then beyond that, it's market driven. So if you have opportunity to do a wet cake or to do your Soul brand as a wet product, you could do that without needing a second dryer. But that's going to be for a plant that's probably west and in some pretty heavy cattle territory that has a single dryer system right now existing. So it really depends on the opportunity and what the customer wants in terms of levers to pull for producing their feed products.
Sure. Thank you. Next question. What is the texture like of your high protein off the rotary dryers?
Yeah. So at Element, what we have right now is a very flowable, I'm not going to call it overly fine, but it's a pretty small particle size feed product. But it like I said, it flows really well. So what we do with the high protein dryer systems, we actually add a roller mill that allows us to tailor the particle size to whatever the end feeder wants. So we could produce a really, really fine, almost powdery high protein feed. There's some people that's what's desired, that's what they want. Or we could do a larger particle size, more similar to kind of a standard distiller's grains if you wanted. But yeah, what we're doing right here at Element, I would say is compared to standard distiller's grains, it is finer.
Great. And we have time for a couple more questions here. Let's see here. Have you measured lysine availability of your high protein coming through a rotary dryer?
Yes. No. Again,
Short
really
answer,
good questions.
yes.
Yeah. I mean, these are the questions that those end users are going to ask, and nutritionists especially. So yeah, we've got a feed innovations team that's worked with Element to do multiple testing of that. So we do have data around that. We've got, I think, 2 different feed sheets that we've been showing customers. So yeah, whoever among the audience asked that question, reach out. Happy to give you information and have further discussion, because that's a good one. Yeah,
again, kind of talking about your dryer. Does the dryer work for sticky material?
The Icm Dryer absolutely can, but that's not ideal. What we're doing with the APP system and the way it's fully integrated, the opportunity to have a sticky, potential screw or dryer plugging material is pretty minimal. And I'd say that's a really good topic for a customer to bring to Element and talk to the operators back there, talk to the management, because they've been running it long enough now to where they've, typically something that's going to bring a sticky product to the back end of the plant is some kind of plant upset. And every plant's going to see that from time to time. But one of the huge values of our FST system, pulling the fiber out in front of fermentation, is we basically give you a system that's very robust in terms of handling fermentation upsets. So yeah, the back end of the plant opportunity to have a real nasty, sticky event is pretty minimal. But even if it does happen, the dryers can handle it, but there's a limit to every dryer system, I believe. So.
Great. Focusing on your grind, do you lose ethanol yield with a larger grind size?
No, that's another really good question, because there's been that thought process in the industry now for multiple years, in terms of a fine grind or a finer grind, allowing ethanol yields or even corn oil yields to increase. We've basically designed within our system the necessary time, temperature, pH levels within a good slurry, a good liquefaction time. We use the SMT system. We basically provide the necessary physical and chemical and biological activity at the front end of the plant to where with our system, we're not going to see a yield loss at all. And in fact, Element is seeing 3 to 3.05 gallons per bushel ethanol yields. And that's it's kind of their just standard. So again, part of the tour and part of what they like to share and talk about. So great question.
Yeah. And then this has been, something that's on people's minds as of late, especially. I mean, it always is. But what is the carbon impact of installing the APP in a plant?
Yeah, that's definitely another one we're talking about. And again, I think the fourth webinar, we'll focus on that pretty specifically. But what we're able to see and model is that reduction of 2 to 4 points, and it's going to be site specific, and it's going to be pretty reliant upon dryer use. So for a plant that's drying 100% of their feed or a high percentage of their feed, they're going to see the biggest reduction in terms of natural gas use and therefore carbon intensity reduction. The other good lever that we're bringing is, if as part of the system we're able to expand production and allow them to grind more bushels, we're able to basically use existing infrastructure, using electrical load, existing natural gas load, and just have more gallons coming out the back end of the plant. So there's potential for reduction there as well. But yeah, we kind of our common stance, our common messaging is it's going to be between 2 and 4 points reduction with the system. And again, as we talk to specific customers, we're able to take what they're doing right now with their existing plant and help them see and understand how the APP will plug and play and provide those benefits.
Great. Thank you. And that is all the time we have for questions today. If we did not get to your question, we will forward it on to the team at ICM and Adam and crew, and they will get back to you and respond. So thank you, Adam. Thank you, ICM. Thank you for doing this webinar. We appreciate it.
Yeah, John, thank you very much for the forum, for this opportunity. Thanks for hosting. We're excited for the next ones too. Great.
Yeah. And so as we look at the upcoming events, I do want to remind you that this is part one of a 4-part series for ICM in their webinar series, looking to the future. Today, ICM's approach to efficient product diversification. So we do have a 4-part series happening. This is part 1, and we are looking forward to having you guys share even more of your knowledge and information and everything that's happening at ICM. So thank you very much. A couple of reminders that we do have our International Biomass Conference and Expo coming up, and that is taking place in March. And I do want to remind everyone that, one, producers of biofuels are free. So if you are an ethanol producer, we do cover a whole section on advanced biofuels, and you can get to that event and join it and attend for free. And that's happening in March in Jacksonville. And then we also have, coming up in June, we have the Carbon Capture and Storage Summit, and that is being co-located with the International Fuel Ethanol Workshop and Expo and the Biodiesel and Renewable Diesel Summit. There's a lot of energy happening around the renewable diesel side and the sustainable aviation fuel side. So you'll see a lot of information coming out on that. So with that, again, we appreciate ICM. We hope you'll join us for our next 3 parts of this 4-part series, and have a wonderful day.